The error in numerically computing the integral from 0 to pi sin x plus cos x into dx using the trapezoidal rule with 3 intervals of equal length between 0 and pi is, so the error is equal to exact value minus the approximate value. The exact value we can calculate by directly integrating this function, and the calculation for approximate value can be done using trapezoidal rule. So let's first calculate the exact value of this integral, which is 0 to pi sin x plus cos x into dx. So this is equal to integral of sin x is minus cos x plus integral of cos x is sin x, and the limit is from 0 to pi. So this will be equal to, so cos pi is minus 1, so minus minus, so this will be plus 1, plus 0 minus cos 0 is 1, so this will be minus 1, and this is 0, so this value, the value of this exact, so the exact value of this integral is 2. Now let's calculate the approximate value using the trapezoidal rule. So using trapezoidal rule, now the function is given here, f of x, which is equal to cos x plus sin x, right? This function is given, and the upper and lower limit is also given, which is 0 and pi. So we can calculate the value of h from here. So first let's write the trapezoidal rule. Okay, so trapezoidal rule, the integral using trapezoidal rule is x naught to x naught plus n into h of the function f of x into dx will be equal to h by 2 multiplied by y naught plus yn. In this case yn is y3 plus 2 times of all the remaining terms, y1 plus y2 plus so on. Okay, so this is actually the area of trapezoids. Okay, so n number of trapezoids we are calculating using trapezoidal rule. Now to calculate the value of h, this will be equal to the upper limit, which is pi, minus the lower limit 0 divided by n number of terms, and n in the problem is 3 because we have to take 3 intervals, so this will be equal to pi by 3. Now let's make the table for this. Since the initial value or the lower limit is 0, so we can write x naught is equal to 0, and h, the height of the interval is pi by 3, so x1 will be equal to 0 plus pi by 3, which is pi by 3. x2 will be equal to pi by 3 plus pi by 3, which is 2 pi by 3. And finally x3 will be equal to pi, 2 pi by 3 plus pi by 3, which is pi. Now the corresponding value of y will be y naught, which is equal to, so y, the value of y is f of x is equal, let's write here y is equal to f of x. Okay, so we just need to substitute in the function the value of x. Okay, so if we substitute 0 here, so cos 0 plus sin 0 will be 1. Now cos pi by 3 plus sin pi by 3 will be approximately equal to, so let's write y1 will be 1.366. Similarly, y2 will be equal to 0.366 and y3 will be equal to negative 1. Now let's use the trapezoidal rule of integration to find the value of this integral. So integral 0 to pi cos x plus sin x into dx using the trapezoidal rule will be h by 2, which is pi by 3 by 2, so pi by 6, multiplied by y naught plus y1, y naught plus yn, so y naught is 1 plus yn, the maximum value of n is 3, so this will be minus 1, plus 2 times of 1.366 plus 0.366. So the value of this integral will be 1.366. 1.8137. Now if we calculate the error, so error will be equal to the exact value that we have got is 2 and the approximate value which is 1.8137. So the error will be 0.1863. Okay, now let's go back to the problem. The error will be 0.1863. For more information on trapezoidal rule, you can refer to the NPTEL course, lecture number 10, Numerical Integration, Trapezoidal Rule, on numerical methods and simulation techniques for scientists and engineers by Professor Saurabh Basu of the Department of Physics at IIT Guwahati.